Let's find the interval and radius of convergence for the given series. Our first try is to say, can I write that as something raised to the k? Since each of these things are raised to the k separately, yes, I can write that as negative x over 11, all raised to the k. I can distribute that k to each of the pieces and we end up getting this, which means that I can apply the root test. Applying the root test means that we're looking at the absolute value of the stuff without the k. So we're looking at absolute value of ak to the 1 over k, which is the absolute value of negative x over 11 to the k, to the 1 over k. K and 1 over k go to 1, so that is absolute value means the negative goes away, so but the x still might be negative, but I could just write that as absolute value of x over 11, which is absolute value of x over 11. That's what's inside the limit. Really, then we're taking the limit as k goes to infinity of this stuff, which is absolute value of x over 11, which is absolute value of x over 11 since there are no k's. As before, we want that to be less than 1. So if that's less than 1, we've got absolute value of x over 11 less than 1. So that absolute value of x is less than 11. So that negative 11 is less than x is less than 11. And our radius of convergence is 1, is 11. Finally, what happens at the endpoints? If x is equal to 11, then this becomes sum of negative 1 to the k, 11 to the k over 11 to the k, which is sum of negative 1 to the k, which diverges. We've seen that 3 or 4 times already for these examples. If x is equal to negative 11, then it becomes sum of negative 1 to the k, negative 11 to the k, over 11 to the k. What really happens here is the k, if I distribute the k to the negative, then it's negative 1 to the k and negative 1 to the k, which will cancel off and make it positive. And so that's really just sum of 1, which also diverges, because it's 1 plus 1 plus 1 plus 1. So that the interval of convergence is negative 11 to 11, including neither endpoint.